Welcome back to Backspace Academy. In this lecture, we'll have a look at the different options that are available for running databases on AWS. We'll then have a look at a database example, and finally, we'll finish up with a hands-on lab where we'll be creating a database server on AWS and then remotely connecting in to that database. The Relational Database Service, or RDS for short, is a fully managed database service that makes it easy to launch database servers in the AWS cloud and scale them when required. The RDS service can launch servers for MySQL, including variations of the MySQL database engine, with MariaDB and Amazon's own enterprise version of MySQL, Amazon Aurora. Standard PostgreSQL is also available as Amazon's Enterprise Aurora PostgreSQL. Microsoft SQL Server and Oracle are also available. Amazon DynamoDB is AWS's NoSQL database as a service. It's a serverless service like Amazon S3, and as such, you don't need to worry about the underlying infrastructure behind it. AWS takes care of everything for you, and it provides high speed, extremely low latency performance. Amazon Redshift is a fast, fully managed, petabyte scale data warehouse that is based upon the PostgreSQL database engine. If you're looking for a big data storage solution, Redshift is perfect for this. Amazon Elasticache is an in-memory data store or cache in the cloud. It allows you to retrieve information from fast, fully managed in-memory caches instead of relying for slower disk-based databases. The AWS Database Migration Service orchestrates the migration of databases over to AWS easily and securely. It can also migrate data from one database engine type to another totally different database engine type. For example, you can use it to migrate from Oracle over to Amazon Aurora. Amazon Neptune is a fast, reliable, fully managed graph database service. It has a purpose-built, high-performance graph database engine optimized for storing billions of relationships and querying the graph with millisecond latency. Now let's have a look at how you might use some of these database services in a real-life example. On the right there, we've got our corporate data center. And inside of our corporate data center, we've got an on-site Oracle database. Now let's just say that Oracle database, it's old, it's worn out, it's outgrown its capacity, and it needs to be replaced. Now you've done a total cost of ownership analysis on the situation, and you've identified that it is far more cost effective to host that database on the AWS cloud. So the first thing that you are going to want to do is to launch an RDS database instance. Now let's say you want to further reduce your costs by not having to pay for the Oracle licensing fee. And what you can do is that you can launch an Amazon Aurora database instance, and that will be running either the MySQL or the PostgreSQL open source database engines. And by doing that, you're not going to be paying for a licensing fee. The disadvantage of that is that some of the fields of data that are located in that Oracle database may not be compatible with the Amazon Aurora MySQL or PostgreSQL fields. And what you are going to need to do is that when you take that data out of your Oracle database, you're going to have to change it and manipulate it to suit the Amazon Aurora database. And that is where the AWS Database Migration Service comes in. You can define a database migration workflow by specifying the source database, the target database, and any operations on that data that need to occur during that migration of that data. Once you've done that, you can then run the database migration job. And that will look after everything for you. It will migrate that data from that on-site Oracle database to your Amazon Aurora database. And at the same time, it will be giving you feedback through the AWS Management Console as a dashboard on the performance of how that job is actually going. Because that job could take hours, it could take days, it could take weeks, depending on how big your Oracle database is and how fast your connection to the AWS cloud is. And it will also give you feedback of any errors and alert you to any problems that may occur. Once our RDS instance is up and running and the data has been migrated over, then we can look at launching a web server that can receive traffic and requests from the outside world over the internet, and then get that data that is required from the RDS database and then return that back to the requester. Now, let's just say we're getting a lot of requests from the outside world, and a lot of that is for the same data. What we can look at doing is getting all of our regularly accessed content and putting it into an Elasticache node. And because the Elasticache node is serving those requests from its memory, not from a solid state drive, as is the case with the RDS service, it will be returning that very quickly and it will be at a lower cost. Now, we need to take into consideration that the costs of storing data in memory is more expensive than storing that data on a solid state drive. And so we need to make sure that that Elasticache node only contains regularly accessed data. So the way that we would do that is that requests would come in from the outside world to the web server. The web server could then check to see whether that data is in the Elasticache node. If it is in the Elasticache node, it will simply grab that data and then forward it back to that requester. Let's just say a request comes in and that data is not in the Elasticache node. So then the web server will go to the RDS database instance. It will get that data if it's there. And after it has got that data, it will then write that data into the Elasticache node. And at the same time, it will define a time to live, or a TTL, for that specific data. And once that TTL has expired, if there are no further requests for that data within that TTL, then that data will be removed automatically by the Elasticache service from the Elasticache node. And by doing that, all of that data that's in the Elasticache node will be regularly accessed data that has been accessed within that time to live period. Now, let's just say a request comes into that web server for either writing to or deleting from that RDS database. So the way that would work is that the request would come into the web server. The web server would then either delete or write to the RDS database. If it is deleting from the database, then it would also delete from the Elasticache node as well. If it's writing to the database, then it would also write to the Elasticache node, and again, it would define a time to live period, so that if that data is not requested within that time to live period, then it will automatically be removed from the Elasticache node by the Elasticache service. Okay, let's have a go at doing this ourselves. In this lab, we're going to be launching an RDS database instance that will be using the MySQL database engine. That will be covered under the AWS free tier, so this lab's not going to cost us anything. Now, because we're launching that within our VPC, which is our own private space within the AWS network, no access will be allowed to that RDS instance unless we allow that to happen. So that RDS instance will have a default security group associated to it. And that security group is a firewall to the outside world. And it will have rules that will prevent access to that database instance. So to allow access to that RDS database instance, we are going to need to create a new security group. And within that security group, we are going to define a rule that will allow access from our remote computer. Then when we are launching our RDS instance, we simply define and associate that security group with that instance, and that database will be launched with that security group associated to it. Once we've done that, we can then install the MySQL Workbench software on our remote computer. And then provided we've got the username and password that we created for that database, we will be able to connect into that database instance and manipulate that database.